Yes, it is permissible to combine receptacles and lights onto the same branch circuit that is AFCI protected. It is also acceptable to extend the circuit to include other rooms, such as an adjoining bathroom. For non-dwelling applications, the 180 volt amps per device rule applies. For dwelling units, the 3 volt amps per square foot rule applies to lighting circuits, and bedroom receptacles are included in this calculation. When wiring a master suite, firstly, calculate the total wattage of incandescent and fluorescent lighting fixtures. Secondly, for fluorescent fixtures, calculate the total computed load of ballasts. Thirdly, add the computed lighting load to the total receptacle load, assuming a reasonable load per receptacle. Fourthly, if the total load is below 1800 watts, which is 15 amps times 120 volts, it is acceptable to use a single AFCI circuit. Note that you do not need to apply 125% for continuous loads when using the 1800 watt rule. For a 2000 square foot house, the minimum number of lighting circuits is 3. The calculation is 2000 times 3, which equals 6000 volt amps, divided by 120 volts, which equals 50 amps, divided by 15 amps, which equals 3.33, rounded down to 3. Depending on the number and type of lighting fixtures, you may need more than 3 lighting circuits. In summary, you can use a single AFCI circuit to protect both lighting and general-purpose receptacles in a master suite, provided that the total load is below 1800 watts. For a 2000 square foot house, you will need at least 3 lighting circuits. Considering AFCI protection for general use outlets in dwelling unit bedrooms rated at 125 volts, 15 and 20 amps, combining receptacles and lights on the same branch circuit is permissible. Extending this circuit to adjoining bathrooms is also acceptable. When calculating branch circuits, remember that the 180 volt amps per device rule applies to non-dwelling applications. In dwelling units, a 3 volt amps per square foot rule governs lighting circuits, including bedroom receptacles. For a master suite, firstly calculate the total wattage of incandescent and fluorescent fixtures. Secondly, compute the total load of ballasts for fluorescent fixtures. Thirdly, add the computed lighting load to the total receptacle load, assuming a reasonable wattage per receptacle. If the total load remains below 1800 watts, a single 15 amp AFCI circuit is suitable. It's important to note that applying 125% for continuous loads isn't necessary when adhering to the 1800 watt rule. For a 2000 square foot house, the minimum requirement is 3 lighting circuits. This is calculated as 2000 square feet times 3 volt amps per square foot, totaling 6000 volt amps. Dividing this by 120 volts gives 50 amps. Finally, dividing 50 amps by 15 amps results in 3.33, rounded down to 3 circuits. Depending on the number and type of luminaires, exceeding 3 lighting circuits may be necessary. In summary, a single AFCI circuit can protect both lighting and general-purpose receptacles in a master suite, given that the total load stays below 1800 watts. A 2000 square foot house requires a minimum of 3 lighting circuits. When dealing with AFCI circuit protection and combining loads, the National Electrical Code, or NEC, provides specific guidelines. Let's delve deeper into these calculations and considerations. Firstly, understanding the scope of AFCI protection is crucial. The NEC mandates AFCI protection for various locations within a dwelling unit, particularly bedrooms. This protection aims to mitigate the risk of electrical fires by detecting arc faults. Secondly, the permissibility of combining receptacles and lighting on a single AFCI protected circuit hinges on adhering to load calculations and NEC guidelines. While it is generally permissible, it's essential to ensure that the total load does not exceed the circuit's capacity. Thirdly, extending the AFCI circuit to adjoining rooms, such as a bathroom, is also acceptable, provided that all applicable requirements are met. This includes proper wiring methods, grounding, and adherence to bathroom-specific regulations. Branch circuit calculations are fundamental to ensuring safe and compliant electrical installations. For non-dwelling applications, such as commercial or industrial settings, the 180 volt amps per device rule typically applies. However, in dwelling units, a different approach is used. The 3 volt amps per square foot rule governs the calculation of general lighting loads, including those in bedrooms. This method provides a simplified way to estimate the overall lighting demand in a residential space. When wiring a master suite, a more detailed approach is necessary. Firstly, the total wattage of all incandescent and fluorescent lighting fixtures must be determined. This involves summing the rated wattage of each bulb or lamp installed in the fixtures. Secondly, for fluorescent fixtures, the total computed load of the ballast must be calculated. Ballasts consume additional power, so their contribution to the overall load must be accounted for. Thirdly, the computed lighting load is then added to the total receptacle load. This typically involves estimating the load of general-purpose receptacles, considering the types of appliances or devices that may be plugged into them. A common approach is to assume a reasonable wattage per receptacle, such as 180 volt amps, although this can vary depending on the anticipated usage. If the total load, including lighting and receptacles, remains below 1800 watts, which corresponds to a 15 amp circuit at 120 volts, a single AFCI circuit can be used. This 1800 watt threshold provides a safety margin to prevent overloading the circuit. It's important to note that applying a 125% factor for continuous loads is not typically required when using the 1800 watt rule for dwelling unit branch circuits. However, if the circuit is expected to serve continuous loads, such as those that operate for 3 hours or more, it's prudent to consider this factor in the calculations. For a 2,000 square foot house, determining the minimum number of lighting circuits involves applying the 3 volt amps per square foot rule. This calculation is as follows. Firstly, 2,000 square feet multiplied by 3 volt amps per square foot equals 6,000 volt amps. Secondly, 6,000 volt amps divided by 120 volts equals 50 amps. Thirdly, 50 amps divided by 15 amps equals 3.33. Rounding down to the nearest whole number, the minimum requirement is 3 lighting circuits. However, the actual number of lighting circuits may need to be increased depending on the number and type of luminaires used throughout the house. For example, if numerous high wattage fixtures are installed, additional circuits may be necessary to prevent overloading. In summary, combining lighting and receptacles on a single AFCI circuit in a master suite is permissible, provided that the total load remains below 1800 watts. A 2,000 square foot house requires a minimum of 3 lighting circuits, but this may need to be increased based on the specific lighting design. Adhering to these guidelines helps ensure a safe and compliant electrical installation. Now, let's expand on some key aspects of AFCI circuit design and calculations to provide a more comprehensive understanding. Firstly, AFCI technology is designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors or to ground, creating heat and potentially igniting nearby materials. Secondly, AFCI breakers are more sensitive than traditional circuit breakers and can detect these arc faults quickly and reliably, interrupting the circuit to prevent a fire. The NEC mandates AFCI protection in various locations within a dwelling unit to enhance safety and reduce the risk of electrical fires. This includes bedrooms, hallways, living rooms, and other areas where arc faults are more likely to occur. Combining receptacles and lighting on a single AFCI protected circuit is a common practice, but it's essential to follow certain guidelines to ensure safety and compliance. Firstly, the total load on the circuit must not exceed the circuit's capacity, which is typically 15 amps for a 15 amp circuit or 20 amps for a 20 amp circuit. Secondly, the wiring methods and materials used must be appropriate for the intended application and comply with the NEC. Thirdly, all connections must be made properly and securely to prevent loose connections or overheating. When extending an AFCI circuit to adjoining rooms, such as a bathroom, it's important to consider any specific requirements that apply to those locations. For example, bathrooms typically require ground fault circuit interrupter, or AFCI, protection for receptacles located near water sources. This is in addition to the AFCI protection required for the branch circuit. Branch circuit calculations are essential for determining the appropriate size and configuration of electrical circuits. For dwelling units, the NEC provides two main methods for calculating branch circuit loads. Firstly, the general lighting load method, and secondly, the appliance and receptacle load method. The general lighting load method, which is based on the 3-volt amps per square foot rule, is used to estimate the overall lighting demand in a residential space. This method is simple and easy to apply, but it may not always accurately reflect the actual lighting load in a particular dwelling unit. The appliance and receptacle load method involves calculating the load of each appliance and receptacle that will be connected to the circuit. This method is more accurate but also more time-consuming. When wiring a master suite, a combination of both methods may be used. Firstly, the general lighting load is calculated using the 3-volt amps per square foot rule. Secondly, the load of each appliance and receptacle is calculated individually. Thirdly, the total load is then determined by adding the general lighting load to the appliance and receptacle load. If the total load exceeds the circuit's capacity, the circuit must be divided into multiple circuits or the size of the circuit must be increased. In addition to load calculations, it's also important to consider voltage drop when designing branch circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. This can cause appliances and equipment to operate inefficiently or even fail. To minimize voltage drop, it's important to use the correct wire size and to keep the circuit length as short as possible. For a 2,000 square foot house, the minimum number of lighting circuits is typically 3, based on the 3-volt amps per square foot rule. However, this may need to be increased depending on the specific lighting design and the types of luminaires used. For example, if numerous high-wattage recessed lights are installed, additional circuits may be necessary to prevent overloading. In summary, AFCI circuit protection is an important safety measure that helps prevent electrical fires. Combining lighting and receptacles on a single AFCI circuit is permissible, provided that certain guidelines are followed. Branch circuit calculations are essential for determining the appropriate size and configuration of electrical circuits. A 2,000 square foot house typically requires a minimum of 3 lighting circuits, but this may need to be increased based on the specific lighting design. By following these guidelines, you can ensure a safe and compliant electrical installation. Now let's delve into continuous loads, NEC Table 310.15b16, and receptacle spacing to further refine our understanding. Firstly, a continuous load is defined as a load that operates for 3 IOs or more at a time. These loads can include lighting, heating, and air conditioning equipment. The NEC requires that branch circuits supplying continuous loads be derated to 80% of their ampacity. This means that a 15 amp circuit supplying a continuous load can only be loaded to a maximum of 12 amps, which is 15 amps times 0.8. This derating factor is necessary to prevent overheating of the circuit conductors. NEC Table 310.15b16 provides the ampacity of various conductors based on their size, insulation type, and installation condition. This table is essential for determining the appropriate wire size for a given circuit. When selecting a wire size, it's important to consider the ampacity of the conductor, the derating factors that may apply, and the voltage drop requirements. Receptacle spacing is another important consideration when designing branch circuits. The NEC requires that receptacles be spaced no more than 12 feet apart along walls in dwelling units. This ensures that appliances and equipment can be easily plugged in without the use of extension cords, which can be a safety hazard. In addition to the 12-foot spacing requirement, the NEC also requires that receptacles be located within 6 feet of any point along a wall. This ensures that no point along a wall is more than 6 feet from a receptacle. These receptacle spacing requirements apply to all general-purpose receptacles in dwelling units, including those in bedrooms, living rooms, and hallways. Bathrooms have additional receptacle requirements, including the requirement for AFCI protection for receptacles located near water sources. Let's revisit the master suite example and incorporate these additional considerations. Firstly, calculate the total continuous load in the master suite. This includes lighting that is expected to operate for 3 hours or more, as well as any appliances or equipment that are considered continuous loads. Secondly, apply the 80% dirty factor to the circuit ampacity. This will determine the maximum allowable load in the circuit. Thirdly, select the appropriate wire size based on the dirted ampacity and the voltage drop requirements. Fourthly, ensure that receptacles are spaced no more than 12 feet apart along walls and within 6 feet of any point along a wall. Fifthly, provide GFCI protection for receptacles located near water sources in the bathroom. By following these steps, you can design a safe and compliant branch circuit for a master suite that meets all applicable NEC requirements. In summary, continuous loads must be derated to 80% of the circuit ampacity. NEC Table 310.15b16 provides the ampacity of various conductors. Receptacles must be spaced no more than 12 feet apart along walls and within 6 feet of any point along a wall. Bathrooms require GFCI protection for receptacles located near water sources. By considering these additional factors, you can design a safe and compliant electrical installation.